PHY 104, motion in multiple dimensions. So till last week we had a break. Before that, we worked on trying to understand the mathematics that is required to do physics in going forward. Okay, so you have learned differentiation, integration, and also some amount of vectors. Okay, and we figured out. Now we are going to figure out how to use them in our physics. Okay, till now in physics we have not been using any of these things till up to 10th standard or so. We were working with some very simple equations called kinematic equations. Okay, so now we are going to move forward and learn more about how to get into a slightly more advanced physics. Okay, so we are going to we are having actually two restrictions on which we are working today. Okay, till now. Okay, what are those two restrictions? So two restrictions on which we are working are Srinivas, I can see you. Can you talk to me? Can you speak? Can you hear me, Srinivas? Okay. So now I'm just starting now. So we are talking about motion in multiple dimensions. Okay. Till in the high school level, we kind of studied up to, okay, all these kinematic equations, Newton's laws, and I'm assuming that all these things are kind of known to you. Okay, so I'm going a little forward now. We are working with basically two restrictions till now. One restriction was we were working with what is known as constant acceleration. Okay, till now we were working with constant acceleration. And we were also working with one more restriction, which is basically motion in a straight line, in one dimension or a straight line. Though we touched a little bit here and there about circular motion and all, but we never really studied motion in a multiple dimensions in a more rigorous way. Okay. So now we are going to basically talk about. We remove these restrictions one by one, okay, and then when we remove those restrictions, we are actually getting into. When we remove the first restriction, we are going to get into directly into calculus. Okay, when we remove the second restriction, we'll go and directly get into vectors. Okay, so these are the two things, vectors and calculus, that we learned till now. We can start using them. So I'm going to basically also talk about a few more things, okay. So which are we're going to touch upon a few more things, which we will study in more detail now. Okay, what are those few more things? One is the graphical representation. Okay, we did a lot of graphical representation. So now we will go a little bit more detail. Okay, graphical representation, and second one is what I call understanding basically the average speed or average velocity. So average velocity we will get into slightly more detail, okay, and understand it in a much more complex scenario. Okay. Then lastly, we talk about relative velocity. That means whenever we talk about velocity, most of the time we discuss about the velocity when we are seeing it from a very stationary frame of reference. We are standing here, a car is moving like that. So now we are going to talk about a car is moving and an aeroplane moving and wind is blowing, all sorts of things coming into picture. Okay, so we are going to mix all of them and understand that. So these are the three things we are going to cover also. Okay, now I am going to first start with basically the first one, that is constant acceleration. This is what we are going to start. And what are the books that I am going to use? I will just tell you a little bit about the books that I am going to use, so that you can also have those books if you want to. Okay. So the first of all, the books that are there for the NCERT books for the 11th and the 12th are very nice books to understand a lot of things. You can buy one of those things and keep it. There are two books for 11th and two books for 12th. Today I am covering mostly 11th syllabus for this year, and also, you can download them. It is available from the NCERT website. And secondly, most important book that one needs to have is basically physics by what is the physics book that I talked about? Sears and Zemensky is a nice book. Okay, I'm not going to ask you to buy that because that is a very big book, this much big book, but I keep reading that book to follow. Okay, and there are a few more books from which I do lots of problems from. Okay, very interesting, nice, complex problems. The one of the simplest book, smallest book, but it's very complex though, is called as Problems in General Physics by I.R. Iredov. This is the name of the book. This is the book. Okay, I will just bring it nearby so that you can write down what is there on this. Okay, if you can read it and write it down. Problems in General Physics by I.R. Iredov. This book, you please take it down. Okay, and next one is that even this book actually, if you take the problem from this book, it is almost like initially feels like impossible to solve. I suggest that you are going to you spend some time trying to solve the problems, but once you are frustrated, give it up, and then take up a solution book. Okay, this is a solution book. There are two such books. This is the first book. Okay, this is called Solutions to Iredov Problems, Volume 1 by Abhay Kumar Singh. Okay, this also sometimes you may not be able to understand the solutions. So, but it will help you to solve problems. So you are now getting into a very, very deeper territory of physics. So it's a very serious work. Okay. So now what I will start is basically the first part I talked about is a constant acceleration. Okay, how to basically come out of this concept called as constant acceleration, and is it available in this real world? Do we see constant acceleration, or do we see things which are not having constant acceleration? Okay, so that is first question that I'm going to ask, and it's a very simple question. I will start, okay, and see whether you can analyze that question. Okay, so let us say you are standing on the earth. This is our earth. Okay, and on the earth, from the earth, you let us say take some distance on the top, somewhere here, let us say 1 kilometer away. Okay, 1 kilometer. I have a ball. Okay, that ball I am going to drop. Okay, and it will fall to the earth. This is a problem, free falling problem, which we have always done and we have always understood. Okay, so I am sure you guys will be able to calculate how much time it takes for it to come from 1 kilometer height to the earth. Okay, how are you going to do that? You are going to use simple kinematic equations. I hope you kind of understand that on how to do that. Okay, I am not going to go very much detail into that, though I will very quickly tell you. So we used to have these three equations. What are those? V is equal to u plus at. S is equal to, correct, ut plus half at square, and v square is equal to u square plus 2as. These are the three kinematic equations which we kept using. Okay. However, now in this scenario, it is very straightforward what equation you want to use. Okay. So in our case, acceleration we take it as g, which is 9.8 meter per second square. Okay, and we know the height, which is 1 kilometer. So I can, let us say, use the second formula and say that 1000 meters is equal to initial velocity is 0. So I will say 0 plus half into 9.8 into t square, something like this. Okay, so if I then calculate t directly, I will get something called as t seconds. Okay, I am not going to write that here. I will not teach you arithmetic. So once you do that, t is equal to that many seconds. Now I can actually that is the question. The question was what is the time taken to fall? Okay, we quickly found out the answer. Okay, however, okay, do we see that this answer to be perfectly right, or is it the answer is approximately right? Okay, that is the question. Okay, so the reason we think that it may be just approximately right is because you see from here to here, when the ball is moving, okay, we always took 9.8 meter per second square as the acceleration. And is that true? Is that the correct acceleration everywhere? Okay, Viraja, what do you think? Is it the correct acceleration everywhere? It may be slightly varying, that is correct. How is it varying? Srinivas, can you tell me how is it varying? Huh? It's more at the poles, that is one way, but I am not going anywhere. At one point only I am doing. So look at this. Now how this 9.8 comes. Okay. So I am just basically going to take this and make it a little bigger so that you can see the distance correctly. Okay. So this is my 1 kilometer. Okay. So now what is happening, you see, is, so anyway, so now look at this. We have to use Newton's law of gravitation to understand the force in the first place. Okay, why is it even falling down? Okay, it is falling down because there are two bodies. One is Earth, another is this. So let us say Earth has a mass capital M, and this small body has a mass small m. So the force on this small body is nothing but F is equal to G into capital M into small m divided by the distance, which I say x, let's say x square. Okay, the x, I will call it as x distance between the center of this body and the center of the Earth. This is x. Okay. So this is basically the force. Okay. Now, force divided by mass is the acceleration. Okay, so the acceleration here is, I can say, F by m. Okay, so now I will say G into capital M divided by small m will go away by x square. So you look at this. This acceleration is changing as the x is changing. So it is inversely proportional to the square of the distance. As the x is changing, acceleration is changing. Okay. Now we are taking that acceleration to be constant as 9.8 meter per second square. So the moment the ball drops by a small distance, very small distance, you know what will happen? The acceleration will increase because it is nearby. When it comes by even a little bit more distance, the acceleration will even now increase. So as it keeps coming down, its acceleration keeps on increasing. It is not constant. So we have approximated it to be constant because we thought when compared to this distance, okay, this small distance is very less. Okay, this is 6,400 kilometers. This is 1 kilometer, which is 6,399 kilometers is the difference. Okay, that means that when this moves from here to here, the difference that happens in the x is from 6,400 to 6,399 kilometers. Okay, so that means basically the a varies very little. So that is why we have approximated it and said that a is always g, which is 9.8. Okay, but in real proper calculation when you want to do, or when you want to go ahead and do the calculations, for example, for satellites which are going around the Earth, satellites are very far. Okay, they are not like 1 kilometer. For example, if you look at the satellite, like geosynchronous satellite, they are 36,000 kilometers from the Earth. Okay, so they are very far. So then we cannot neglect this x. So then we have to deal with proper accelerations, which are basically continuously changing. So that is about satellites. But when we try to understand, for example, how Earth is moving around the Sun, or Moon is moving around the Earth, or other planet movements, everywhere, okay, the acceleration does not stay constant. Acceleration keeps moving. Okay, in such scenarios, hello. Tell me what is your question, Vishnu? How did they calculate mass of Earth? That I already told you, no? The other day I talked about, there was one guy whose name is Can somebody tell me the name of the guy who calculated the Cavendish? No, mass of the earth was Cavendish. Henry Cavendish. Okay. Henry Cavendish actually calculated the mass of the earth. You can figure that out. That's he used the torsion balance and all. So you can go in the web and check how did he measure the mass of the earth. Okay, that is easily available in the net. Okay. So anyway, so this acceleration of the mass which is coming down here is not constant. That is what I wanted to tell you. Okay, till now we were thinking that it is constant. So now when it is not constant, how do we actually solve this case? If I ask a question, how much time it takes for it to come from here to here, I can't use this formula. This formula can be used only when acceleration is constant. Okay. So now let us see how to do that. So you try to do this integration and try to solve this problem. Now this problem actually is called as a differential equation. I will tell you why it is a differential equation. So look at A. What is A? A is nothing but rate of change of velocity. Okay. So we can say A as dv by dt. Okay. And which is equal to gm by x square. And what is V? V is actually dx by dt, rate of change of position. So we can say d by dt of dx by dt. Okay, which is equal to gm by x square. Correct. Rate of change of position. Okay, displacement. Change in position divided by time. Okay. rate of displacement, or rate of change of position, or rate of displacement. We can use both words. Okay. So now this can be written as, actually, what can we write this? D square x by dt square. Do you remember the second derivative that we talked about? Is equal to gm by x square. Okay. Now generally there is one more notation actually. We also use another notation. Whenever we say dv by dt, we write it as x dot. Means once, sorry, dx by dt. Once if we differentiate, we will put 1 dot. Okay. So twice if we differentiate, we will put 2 dot. That is one more notation. That is called Newton's notation. Newton used to use this notation. Okay. X double dot is equal to gm by x square. This is basically, you can keep it like this only. It is just another notation. Okay. So x double dot is equal to gm by x square is called as a differential equation. Why is it called a differential equation? Because it is an equation of just one variable. Okay. So there is one variable x here, it is the same variable x here. But it is not the equation of that variable. It is the equation of the derivative of that variable. Okay. Double differentiation here. So hence it is called a differential equation. There are differentials here in the equation, and hence it is called differential equation. Solving the differential equation to some extent is there up to 12th, but full detailed differential equation solutions, how to do, we will not go into details of that. I will show you some simple things that are useful for you. Okay. So now this, for example, this equation, if you solve, what is the meaning of solving this equation? Solving this equation simply means writing a function called x of t, which is equal to something in the form of t, maybe t square divided by 2 plus 1, whatever, some long equation of x of t. So it is x as a function of t, we can write an equation. That is called as a solution to the differential equation. So are we going to do all this to try to do solution for this equation? Yes, but towards the end, when we have learned everything. Okay. Now we are going to go there in steps. We are going to learn this in steps. We can't do it in a one time suddenly doing the differential equation solutions. Okay. So what we are going to now do is, I am just telling you, okay, to make you understand that acceleration being constant is just an approximation that we have used till now in our life, which is not going to be true. But in most scenarios, that kind of a approximation works. So sometimes when we go exact calculations, it is not possible to use that. Okay. So you take it down quickly just as an example of non-constant acceleration, varying example of, this is an example of varying acceleration. This is not a constant acceleration. It is varying acceleration. Okay, this is an example of a varying acceleration. Okay. Now I will give you one more small example of a varying acceleration and then move forward to see what can be done. Okay, how do we go ahead trying to solve the problems of that kind? Let me start with one simple problem. Okay. So you can take down the problem. Take down the problem. Acceleration of a particle is given by the equation A is equal to 2t. Find the distance traveled by the particle in 10 seconds. Find the distance traveled by the particle in 10 seconds. Assuming in the beginning velocity is 0. Assuming in the beginning velocity is 0. Which means basically at t is equal to 0, v will be equal to 0 and x also will be equal to 0. This is our initial assumptions. Okay. So let's now see what would be the distance traveled. No, definitely not. Okay. So now this is not possible to be solved using these equations. Okay. Because acceleration is not constant. Why do we know? How do we know acceleration is not constant? A is equal to 2t. Okay. So what is the meaning of A is equal to 2t? A is equal to 2t means as the t is varying, okay, acceleration also is varying. So that means, and when t is equal to 0, acceleration is 0, at t is equal to 1, acceleration is equal to 2, at t is equal to 2, acceleration is equal to 4, like that it is varying. Okay, now you may want to try with this, but it is not going to work. So this is the first problem. I will show you how to do this kind of problems. Okay, one more problem you try to solve after this. Okay. Yes, it is. Okay. So let me see how to solve this. Let me show you how to solve this problem. No. It's not going to work like that, Vishnu. So watch exactly how to solve this. Okay. So please give careful consideration because it involves multiple steps. Okay. So and this is you are going to learn basically such problems how to solve. Okay, the basic steps involved in that. Okay. So now I am going to write here A is equal to 2t. Okay. So if A is equal to 2t, okay, I will write A as dv by dt is equal to 2t. Okay. So once we write dv by dt is equal to 2t, I am going to do like this. Okay. dv is equal to 2t into dt. So I have taken basically dt on the other side. Okay. Some of these things we have done in during our integration scenario. Now I am going to basically integrate this. Okay. integrate. Okay, why do I do integration? Because we know that the integral of dv, okay, what is integral of dv? So I talked about basically dv is nothing but small piece. Okay, once on such all pieces, if whole, this is called whole of, this is little bit of. You remember I talked about the whole of little bit of dv is basically v itself. You take v and cut it into small pieces and put all of them together. That is nothing but v. Okay, so by doing so, suddenly we are going to get v from a. Okay, so that is the idea. So now on the other side, 2 is a constant that we can take it out. Integral of t dt, we remember how to do the integration of that. Okay, that is given by t square by 2 plus c. The plus c cannot be forgotten. Okay, if you forget plus c, no integration is right. Okay. Now, this can be written as v is equal to t square plus c. Okay. Now understand one important thing here. We need to understand what is the value of this c. Otherwise, it becomes difficult to calculate after this many seconds where the particle is. Okay. So what we will do is we will find out, okay, what is the value of c. How will we find out? We have to apply initial conditions. This is an important step during this whole process, applying initial conditions. What is our initial conditions? At t is equal to 0, v is equal to 0. That is our initial condition. At t is equal to 0, v is equal to 0. So I will put t in the place of t, put 0. In the place of v also I will put 0, and I will see what will happen to c. Okay. So 0 is equal to 0 plus c. Therefore c is equal to 0. Okay. Now we got the value of c. Okay. Now once we got the value of c, put it back into the equation. So what is our velocity equation now? T square. That is how. Okay. That is our velocity equation. So now once we got the velocity equation, now we get greedy. We want to find out the equation of the motion itself, which means that how is x varying. Okay. So we want to find out the distance traveled. Okay, displacement. So what we will do is I will write it as dx by dt. Okay. So once you write dx by dt is equal to t square. So we know dx is equal to t square into dt. So now I am going to integrate again. Integral of dx is how much? Yes, x is equal to, this is how much, t square. So t to the power of n, when you integrate, you get t to the power of n plus 1 by n plus 1. Okay. So this is t to the power of 3 by 3 plus c. Correct. Okay. Now when you get, now you have to again calculate what is the value of c. For that I will say apply initial conditions. If you are not doing this, in the next problem you will have serious problems. Okay. So apply initial condition where at t is equal to 0, x will be also equal to 0. That is the initial condition which we have set. Okay. So by applying so, we get c is equal to 0. So then what happens? We got x is equal to t cube by Correct? Now x is equal to t cube by 3. And in the beginning, what is the value of x? 0. Okay. At time t is equal to 10 seconds, where is x? Yes. So at t is equal to 10 seconds, x is equal to 10 cube by 3, which is equal to how much? 333.33 meters. Okay. So that is the first problem. So now we did simple kinematics, but we did not use our kinematics equations. Instead we have used integration. Okay. So now you understood what is the value of x. I hope you understood this. Please, if you don't understand, ask now, because my every problem gets 10 times more complex from the previous problem. So please ask questions if you don't understand. Ask. Vishnu, you have some doubt? No. Okay. So please take it down. I will give the next problem. Write down. A particle is moving with an acceleration of a is equal to root t. Find the distance travelled by the particle in 4 seconds. If its initial position is 2 meters from the origin and initial velocity is 10 meters per second. Okay. So initial velocity, I'll say at t is equal to 0, x is equal to how much? 2, and v is equal to 10 meters per second. So this is the problem. Now I will give you about 3-4 minutes. Let us see whether you can do. And I am not going to erase this, because this problem will help you to know what are the steps and follow exactly the same steps. So let's start. Okay. I am going to start there. What is the given question? A is equal to root t. Okay. Okay. So dv by dt is equal to root t. So this is nothing but t to the power of half. This is t to the power of half. Okay. So now 2 is not there here. Okay. We'll remove that. So t to the power of half, when you integrate t to the power of half, what will you get? T to the power of half plus 1 by half plus 1, which is t to the power of 3 by 2 by 3 by 2. Sorry, not here. Here. 3 by 2 divided by 3 by 2, which I am writing it as 2t to the power of 3 by 2 by 3. Okay. Plus c. So, which is nothing but 2 into t to the power of 3 by 2 by 3 plus c. So, now applying the initial conditions. Okay. At t is equal to 0, what is our V initial condition? V is equal to 10. Okay. So, we are going to put here 10 instead of 0. So, C becomes what? C becomes 10. Okay. So, when C becomes 10, our equation now is 2t to the power of 3 by 2 by 3 plus 10. So, this is again 2t to the power of 3 by 2 by 3 plus 10. Okay. So, again same thing I will write here. 2 by 3 is outside plus 10. So, not outside, sorry, I will write it here properly because it takes slightly more space. Okay. Integral of dx is equal to integral of 2t by 2t to the power of 3 by 2 by 3 plus 10 whole dt, like this. Okay. So, that will come to left side, it is anyway x we know. Okay. Now, t to the power of 3 by 2, when you integrate, it is t to the power of 3 by 2 plus 1 divided by t to the power of 3 by 2 plus 1, which is t to the power of 5 by 2. Okay, divided by 5 by 2. Okay. I will write it as 4t to the power of 5 by 2 divided by 15. This 3, okay, into 5 by 2 down is there. That 5 into 3 is 15. These 2 will go up and it will become 4. Okay. Plus 10, if you integrate, what will you get? 10 when I integrate with respect to t, I will get 10t. Okay. 10 is the constant. Okay. When you integrate a constant with respect to t, you will get t, isn't it? Because t, when you differentiate, you get 1. 10t, 10 is there into 1. 1 is becoming t. Say if you have 10t, if you are having 10t, if you differentiate 10t, what will you get with respect to t? You will get 10. So, if you integrate, you will get 10. Okay. So, plus c, there is a c here, which we cannot forget. Okay. So, now we are going to apply initial conditions. What are our initial conditions? At t is equal to 0, at t is equal to 0, x is equal to 4. X is equal to 4. That is our initial condition, correct? X is equal to 4 or 2? Huh? What did I give in the question? X is equal to 2. 2. Okay. Okay, okay. Okay. Now, let us give x value as 2 is equal to 10 is equal to c directly. That's all. Because t is anyway 0. No? C is equal to 2. So, what is our final x equation? X equation is 4 t to the power of 5 by 2 divided by 15 plus 10 t plus 2. Okay. Now we have to calculate for t is equal to 4 seconds, what would be x? Okay. So x is equal to 4 into 4 to the power of 5 by 2 divided by 15 plus 10 into 4 plus 2, which is nothing but, this one you see, 4 to the power of 5 by 2 is nothing but square root of 4 is to 2 power 5 is 32, 32 into 4 is 128. Okay, 128 by 15 plus 42, which is nothing but 50.5533 meters, 3 recurring meters. Did you get it? Srinivas, where did you go wrong? Did you tell the 50.33? Then you are right. I don't know. I heard it wrong. Sorry. Yeah, I heard it like that. Anyway, Viraja, did you understand this? Oh. 30? Okay. So now we have done a little bit of practice on this now. I am now going to go ahead and do a slightly more complex one. Okay. So write down this question. Derive the kinematics equations using calculus for A, the first one, okay, first part, constant acceleration and B, the second part is derivative of acceleration is constant. So I will repeat the question again. Derive the kinematics equations using calculus for A, constant acceleration, B, derivative of acceleration is constant. Okay. Assume, lastly, write down this part also. Assume the initial velocity to be u, and initial acceleration to be a naught. Okay. So I hope you first of all try to understand the question. So there are two parts to this question. Okay. First part is actually normal thing that we have been doing, that is constant acceleration. Okay, first part is constant. For constant acceleration, you already know the kinematics equations. That is, let us say we will take two equations. uv is equal to u plus at and s is equal to ut plus half at square. Okay, these two equations we have to derive using calculus. Okay, and second part is variable acceleration. But the rate at which it is varying is constant. So let us say a is equal to some k into t. Okay, that means that if you look at this now, if you take the derivative of this acceleration, that means dA by dt. What will be dA by dt? K. Okay, because kt, if you differentiate, you get k. Okay, that is my condition. Second part I am saying derivative of the acceleration is constant. Okay, so the acceleration can be taken as a is equal to kt plus a naught. Why do we have to take kt plus a naught? Because I told you that initial acceleration is a naught. That means when t is equal to 0, a should become a naught. Okay. So in this case, you are going to do with a constant acceleration. In this case, you are going to do with the acceleration starting from a is equal to kt plus a naught. So we are going to derive the kinematics equations for v and s. Okay. The first one I will show you, which is very easy. The second one you will do, which is not that easy. Okay. We will start from acceleration is constant. Okay, I will put it as some constant, let us say c. Okay. Now, this is nothing but what? dv by dt is equal to, see, I am not going to do anything else other than what we have been doing in the previous problems. No changes in the steps. Okay, dv by dt is equal to c. This implies dv is equal to c dt. Okay, this simply implies integral of okay, this is nothing but v is equal to ct plus c. Correct? So what is our applying? This step is all something that people always either they neglect, okay, or they don't want to do this step. That is when most people go wrong. Applying initial conditions is the only important step in all these things. Initial conditions. Keep writing that all the time. Practice writing this line. Take a copy book and write applying initial condition, applying initial condition. Otherwise you will not do. I have seen people writing in the exams even after a BSc, MSc, wherever they go, BE when they do, everywhere they forget to apply initial conditions. Okay. And the whole problem lies inside that. So please practice this. Okay. Applying initial conditions. So at t is equal to 0, v is equal to u. We have been told that. Okay. Therefore, v is equal to u plus ct. See, at t is equal to 0, you put 0 here. Okay, and at place, see, I'll show it. Okay, one step I actually skipped. Okay. Let me do the other step also. I know once you skip one step, there is a difficulty. At t is equal to 0, v is equal to u. In the place of v, we will put u is equal to 0 plus c. Therefore, c is equal to u. Okay. So put this into this. Therefore, v is equal to ct plus u, or v is equal to u plus ct. C is a, so we got our first equation. If you take a as a constant acceleration, instead of c, we can say v is equal to u plus at. Okay. Now we will go to the next step. So we will say dv by dt. V is nothing but dv by dt is equal to u plus at. Sorry, not v is equal to dx by dt, or not dv by dt. Okay, dx by dt is equal to u plus at. Dx, correct. Dx is equal to u plus at dt. Integrate. So now what we will get? X is equal to, okay, u, when you integrate, u is a constant. You integrate constant, you will get ut plus a, you keep it like this. Okay, t you integrate. What will you get? T square by 2 plus c. Correct. So applying initial condition. At t is equal to 0, x is equal to 0. Therefore, 0 is equal to 0 plus 0 plus c, which means c is equal to 0. So the equation is x is equal to ut plus half square. AT or CT, whatever you want to take. Okay. Actually, you have to take CT because we got C. But anyway, it doesn't matter. A is a constant we can use. C is A. So you got these. Kinematics equations, two kinematic equations directly from our basic assumptions of calculus. Okay. Now you do the second one. Part B you are going to do now. So you start from here now, instead of starting from A is equal to constant. A is equal to C is where we started. Instead you start from A is equal to KT plus A naught. Okay, so what I am going to do now is, this I know you can do it. Okay, it is just a matter of a little bit of time for you to do. I am not going to solve this on the board. Okay, and if somebody has not solved this, please go home and solve this. Or you are already at home, you solve it afterwards. Okay, so now I am going to take one serious problem now. Okay, just one last serious problem. We will try to solve this. I am not assuring that we will finish solving it. Okay, so what is very important is that these problem solving sessions are at the core of learning in physics. Okay, so it is not about quickly solving a problem. It is about understanding how to solve a problem. Okay, so I am going to take one serious Irido problem. Okay, which are like a J kind of a problems. Okay, so we will solve one problem. We will try to at least try to solve one problem. Okay, write down. Whenever I am actually giving a Irido problem, I am going to write it here as exact problem number. Okay. So you also keep it like this so that whenever you want to refer it back, you can refer it back to that. Okay. So I will dictate the problem, take it down. The velocity of a particle the velocity of a particle moving in the positive x direction varies as v is equal to alpha root x, where x is a positive constant. Sorry, not x. Where alpha is a positive constant, not x. Okay. Where alpha is a positive constant. Assuming that at t is equal to 0, particle was located at point x is equal to 0. Find A, the time dependence of the velocity and acceleration of the particle. That means v of t and a of t. Time dependence of the velocity and acceleration of the particle. Okay. And second part, the mean velocity of the particle averaged over the time the particle takes. The mean velocity of the particle averaged over the time that the particle takes to cover the first s meters of the path. Yes, meters of the path. Okay, that is the question. So now let's first understand the question. It is not necessary to quickly solve the question. Okay, let's understand the question. So till now our advantage was, okay, whenever we were given v, okay, they were given in as a function of t, and it was easy for us to move forward. Even when the a was given, it was a function of t. Now the function of we are actually given a differential equation. If you look at this is nothing but x dot. X dot is equal to alpha root of x. X dot I mean dx by dt. Okay, so that is what is given. Okay, now we are asked to find out v of t and a of t. Okay, and maybe x of t also we can find out. So our difficulty is now how do we go ahead? How do we even try to make this work? Okay, so this is how generally any competitive examinations problems look like. Okay, so mainly because it will not be very straightforward. Okay, whatever till now we have been doing is very straightforward. Okay, so we know a certain steps and we go by steps. Okay, now we have to think. Okay, now I think Srinivas, you may have an idea about how to solve this problem. Do you have some idea? Let's discuss. Yeah, how do we do that? Correct. We want to do. See, this is basically called as, this technique is called as, correct. This technique is called as separation of variables. That is a technique. Okay. So what is the meaning of separation of variables? Now we know that in our earlier scenario, what happened was, we were given, let us say, okay, v is equal to some something into, let us say, at square or something like that is there, assume. Okay. Now we used to do this one as dx by dt is equal to at square, and we will say dx is equal to at square into dt. Now what we used to achieve was, on our left side we all got only x's, and on our right side all t's only. No x on the right side and no t on the left side. And one side we are actually differentiating with respect to x and integrating with respect to x, and other side we will integrate with respect to t. Okay. So that is how we used to do till now. But now here also we have to be able to do like that. Then only we can actually solve these problems. We have to separate variables, so such that on one side you get one kind of variables and the integration of that kind, and the other side you get, let us say, all t variables and integration of t kind. Okay. Here we have to try something like that. But the moment we write here, for example, dx by dt, our difficulty is here alpha root x we can write. Okay. If you go ahead and say dx is equal to alpha root x into dt, what is the problem now? How do we do this? So first of all, now we have to make sure that on one side we will have to have on one side x's and other side t's. It is possible, no? Straightforward. Correct. So this can be simply written as, can we do this? Isn't it? We just took the root x this side. And in this problem it is very straightforward. We got to wherever we wanted to very quickly. So we separated the variables. Okay. Now once we separated the variables, ball is in your court. Try it now. Integrate it. Katti, are you able to do it? Understand it? You are seeming to be wondering about what to do. So let us see what let others do. Okay. So tell me, what is the value of x? I want x in terms of t, no? Correct. That is correct. That is the x. So what was our question? Look at the question also. What do we have to find out? What is, so we have found out x only. Okay, this is x of t. What is v of t? V already given. In the place of x, you have found out the x. Substitute it. So x to the power of minus half into dx, I integrate both sides. Okay. This is basically x to the power of minus half plus 1 divided by minus half plus 1. Minus half plus 1 is basically plus half, which is root x. Okay. Divided by minus half plus 1 is this 2 root x. okay, is equal to alpha into this one is just t plus c. What are you saying? Yeah. We'll come to that, Vishnu, 1 second. Just wait, Vishnu, wait. Okay. So based on the initial conditions, when t is equal to 0, x is equal to 0. That we have been told. Okay. So C is applying initial conditions. C is equal to 0. Therefore, 2 root x is equal to alpha t. So, x is equal to, root x is equal to alpha t by 2. X is equal to alpha t by 2 whole square. That's what we got. Okay. Now, if you want to get basically v out of it, we know this formula. Substitute this back into this. V is equal to alpha into root x. Root x is alpha t by 2. So, which is nothing but alpha square t by 2. Okay. Now, I want to calculate A, which is very straightforward. A is equal to dv by dt, which is equal to alpha square by 2. That's all. Now, when you look at this final answer, you suddenly realize that this is not a varying acceleration at all. This is a constant acceleration system. Okay. Once you get a constant acceleration system, the whole thing gets very simple. Okay. Everything else you will now start using the original formula. E is equal to 2 plus at, s is equal to e plus half square, u square is equal to u square plus 2s. All the formula you can use now. Okay. The job becomes very simple. Okay. Because the acceleration is alpha square by 2. Alpha is a constant. Alpha square by 2 is a constant. Acceleration is constant. Acceleration is not a function of t. Okay. So, suddenly now if you want to calculate, question basically asks this, to travel a distance s, the mean velocity is how much? Okay. So, mean velocity is simply average velocity. Average velocity is nothing but total distance travelled divided by total time. See, I will tell you what is the answer. Okay, I will tell you what is the answer. No, you work it out, no problem. You work it out. So I am telling the answer because later you can verify. Okay. Answer is, this is the answer. Okay, you can work it out. Okay. So what is the time now? 7:16. Okay. So if anybody has, okay, I don't want to continue now. It is already, we are already about 15 minutes delayed. So now I will just give you the problem number of Iridov. If you have the Iridov with you, you can solve that problem. If you do not have, I will do the problem next class. Okay. So I am going to solve the problem next class. 1.23. Next problem. 1.23 of Iridov we are going to solve. Okay. But now not. But if you can solve at home, great. We will come and solve other problems also. Just try solving this problem as a homework. You try. If you do not have Iridov, okay, then I can dictate the problem. Do you want me to dictate the problem? Okay, write down. A point particle moves in a straight line. A point particle moves in a straight line with deceleration whose magnitude depends on the velocity v with the deceleration whose magnitude depends on the velocity v of the particle, as A is equal to k into root v. Okay, A is equal to k into root v, where k is a positive constant. K is a positive constant. At the initial moment, velocity of the point is equal to v naught is equal to 4 meters per second. And it starts from the origin. Full stop. What distance will it traverse? What distance will it traverse? Traverse means travel. Okay. Traverse means travel. Okay. What distance it will travel before it stops? And what time will it take to cover that distance? To cover this distance. Take the value of k. Take the value of k as 4 by 3. Now you put k, in the end you put substitute 4 by 3. Okay. So this is the question. See whether you can solve this, and let me see whether anybody comes with a solution. Okay. If not possible, don't worry. It is important that you put effort. Okay. So you spend at least half an hour trying to solve this problem. That is when your brain develops, not when you quickly solve the problem. Remember this. Okay. Now onwards, whenever you attend this class, after that you go and spend some time trying to solve the problem. Okay. If you cannot, then I will help you, don't worry. It is important that you put enough effort to solve the problem. Okay. Okay. Shall we call it a day? Okay. Any doubts? Any doubts? No. Okay. Good night.